The future is now. You can watch girls mud wrestling on one channel, or play Mortal Kombat with a friend in Vietnam, or do stupid laser things like this. Or learn to weld and do things proper, what this thing is meant for. Stay tuned. Welcome back to Fabbin Adventures, guys. Today we have a very interesting video going on. We are going to review this Xlaserlab X1pro Laser by Photonics. And they did send this to me, but if you've watched my drone video, you'll know I don't amp things up. If it's a piece of crap, it's a piece of crap. If it's awesome, I'll let you guys know. And we're gonna go in depth on this machine here. And I'm going to show you some stuff that I'm not seeing anybody else show on the internet. I did a little welding, a little playing with this thing, not a whole lot, but a little bit. And it's kind of neat. It's kind of neat. It's kind of impressive, and it's kind of dangerous. I did end up cooking the tip of my finger with a shot through a corner weld. I was trying to tack a weld, and it shot through the crack and into my finger where I was holding the piece of material to be tacked. And I knew this beforehand, not saying that I didn't know that I could shoot and burn my finger, but I knew beforehand and whatnot. And it just shot through the crack, shot through my leather glove and burnt the tip of my finger. So it is a dangerous little machine. Watch where the beam is going. It'll cook your eyes and whatnot. Wear the appropriate PPE when you're using this machine. Pretty cool. But let's get on to this. Just want to say one thing. If you think you know how to weld, you can pretty well forget a lot of your traditional welding stuff with one of these settings, power, wire feed, all that sort of stuff is different. This is a whole different unit out here. So come with an open mind and run this machine how it's meant to run. Don't try and run it like a MIG welder or an arc welder or whatever. Run it how it's meant to run, and you'll be a lot more successful. Anyhow, this welding helmet is laser rated. It's rated at the proper nanometers that the laser beam that comes out of this projects. And so you can't just wear a regular welding helmet. You need one that protects your eyes from the wavelength that the laser produces. And this does that. And if you wear glasses, if you're somebody that wears reading glasses or whatever glasses us older guys need to wear that stuff to be able to see what we're doing, the helmet is where it's at. It also comes with regular glasses, and that's all right for cleaning because I don't need to see fine detail. But for welding and cutting and stuff, I gotta wear my glasses, put the helmet on. Comes with this remote emergency stop. It's got a magnet on it. So you can put that wherever you're working. If something goes wrong, you can hit that button and a remote shut it off. Obviously, it comes with the gun and the ground clamp that you'll need. Attach it here for cutting and cleaning, and attach it to your work for welding. Obviously, it comes with it comes with a bunch of tips, cutting, cleaning, welding tips, and it come with 2 boxes of these, so I think these things will last quite a while from what I've been seeing. What may or may not last quite a while is the lenses. It has a protective lens in here. If you are cutting straight up and down, the laser can reflect straight back up and start cooking your laser lens. So they have a protective lens in here to protect the mirrors and stuff that are in here, because the mirrors zigzag around and they shoot the laser at an angle or a sweeping motion side to side, back and forth in here. So there's mirrors in here that are adjusting the fiber optic beam down in there. So you don't want to cook those mirrors, so they have a protective lens in there to save that. Sorry if I'm going on and on about it, but lots of people don't know about lasers. I've got I've got a diode laser, a CO2 laser, and a fiber laser over there that I do other projects with. So they do give you a few protective lenses. I cooked one right away, and I'm not sure how I did it, but obviously I was doing something wrong. Also comes with a little apron. As you can see, I've never even taken it out of the package. I wear my typical normal welding PPE. Comes with the unit itself here. This is 700 watts, and it's not the strongest machine out there. Like your big commercial machines will be way more wattage, 10, 20,000, maybe more than that. X-Tool has one out that you can buy now. I think it's about 1,000 watts. But it's pretty impressive when you understand how the laser thing works, what you can actually weld with this. And I believe I was welding stuff thicker than anybody else that I watched on YouTube doing reviews on this thing. Produces some pretty cool little welds, like super fine little welds. Welding this, I think that's 14 gauge. I've done some stainless steel and aluminum and whatnot. Welds really super consistent beads and whatnot, and it's really controllable, the stuff that you can do. Also comes with the wire feed here, and it's a motorized wire feed. It feeds wire similar to a MIG machine where the motor drive is integrated into the machine. This is separate, more like you'd see in the industrial shops where you got a power source and a wire feed separately, and it seems to work pretty good. Typically feeding aluminum wire through a long cable like this can be a problem, so I'm running 045 I believe in here, and I did have one bird's nest, but I may not have had the thing set up properly. Anyhow, let's stop going on about this stuff. You can see all the unboxing, you can see the setup and all this stuff on lots of other people's channels. It's really simple to set up. All the plugs are set separately, so you can't ever mix them up. You just screw them in. If it fits on and screws on, that's the way it goes. Really easy. The one thing you'll need to get, though, is some way to hook up air, which they don't give you any of these extra pieces. This is a 6mm tube, and your gas, your argon, your nitrogen, and your air goes through this tube. So you need a way, what I found, is to have a quick disconnect that you can quickly disconnect this, put it into the nitrogen tank or regulator, or put it into your argon regulator, or go back to air. And as simple as pushing that. So you'll need to get some of these here, not sure what they call them, but just like a quick push connect fitting. All right, let's turn this thing on. We'll just switch on at the back. Comes on, it has a real nice touch screen display on this. Works very nice. Just the lightest little touches. Takes you from welding, cutting, and cleaning. You don't have to hit it hard. It works just like your iPhone or whatever. So you can see touch cleaning, and let's just start with cleaning because it's easy to show you guys. Hit confirm. It's going to have an alarm here showing the interlock. You click that. Now it's saying the e-stop. Click that, and now it's saying atmospheric pressure, and that is your air supply. We'll connect that. That should take care of that. It'll go back to e-stop reset, and here you're going to see e-stop reset. You hit that, everything's green, she's good for go. Hit back, and it's already selected 40% power, 2000 frequency, 100% duty cycle, and a width of your beam. That's what it sweeps back and forth, is 8mm. You turn on, it'll give you this warning saying wear glasses and respirator before starting the laser. You hit confirm, and then it'll let you turn it on, and she'll be live and ready to start producing a laser beam and doing some cleaning. So let's see at this setting what it does. You want to have like an aluminum backing plate or something like that. If you have wood behind here and you go off of your rusted spot onto the wood, it's going to start burning that. So we'll want to take this welding tip off. I believe this was the cleaning tip. And the welder is shut off right now, so me putting my hand in front of here is safe. We'll go turn the laser on now, and we should be good to clean. And I'm not sure, but I'm guessing you need to be about this far away, but let's try it. And like, it really reacts with rust and junk. See how it's not really doing anything to the aluminum? That's why I use an aluminum backer. These are just some garden stakes I made for the wife that were rejects, and they sat outside and they got a little rusty. Pretty much took the rust right off. All right, and these things do get warm and hot. If you spend enough time there, you can burn the mill scale right off of this. But this thing is actually quite warm to the touch, quite hot out here actually. Let's try something with a little more rust and some paint. That's what the original side looked like. That's what our clean side looks like. So a little more playing to figure this thing out, but pretty amazing. Here's a chunk of channel iron. It's got some paint on it. Let's see what we can do here. Let's try further away and see what it does. Further away you go, the less power you have, the less gouging into the metal it does also. See how you can't make that same track, but it's just clearing rust off. We go in closer, obviously the laser gets more focused and more powerful, and here we're burning mill scale off. So for a welding application and you want to burn the mill scale off, this thing would work pretty good for that. If you just wanted to blow rust off it quick for painting, you run her up a little higher. You can also play with the frequency of the machine and the power output and whatnot if you need to be more aggressive and whatnot. But pretty darn neat and handy for getting rust. And you'd be able to get rust out of spots, intricate spots that would be a real pain in the butt to sand in there, or I mean sandblasting, you could do it, and this thing has warmed up. Quite hot up here where I was really hitting it and burning the mill scale off, but pretty awesome if you ask me. Clean the rust off that, no problem. Here's a file. Here's an old file. This one's not really rusty. I did work on one that was rustier, and I played with this one a little bit. You can see this section here that I cleaned. Let's clean the rest of it. Let's see if it actually improves it. Like, it's not cutting nothing. It's just gliding off there. Let's see if we can clean this one up. Look at the junk coming off of there. There was oil on there. So we're burning the oil off the surface of the file. Looks pretty good. Let's do the other side. gonna have to put a glove on for this. It's gonna be hot. It feels like it's got more bite to it. Yeah, the old file, she's pretty wore out, but there's a little more bite to it again. But she's an old wore out file. Just something I thought it would be neat to show you where it's possible that you would be able to rejuvenate. Like you can feel that it's got more bite than it had, and she's warm. All right, let's go on to cutting. All right, so what I did is just for cutting, just to make things easier, I took the wire feed nozzle off. Just gets it out of the way. And now we're just gonna put on our cutting nozzle. Basically as simple as taking the cleaning nozzle off, and we'll just put him back in there. And you put the cutting nozzle on here. And then this tip here is adjustable, I'm guessing maybe to fine-tune your focus height. I'm guessing, but the instructions that come with this are really vague. I wish they would put more information on settings and how to adjust stuff and how to focus the laser and stuff. You can find it online. If you go onto YouTube and whatnot, you can find instructions on how to focus the laser by moving this tube in and out and getting it, when you get it cutting, it basically makes the most noise and the most action, and you call that focused. The other thing is, you can see this tip looks burnt here. I didn't have the laser dot focus dead center, and I think it was hitting this tip, and it was hit when I was trying to cut before. It was turning this tip red hot, and I don't think it should do it, but you do have a pretty small hole to get that laser to come out of, like dead center. When you turn it on, you can see the dot. You can see for lack of a better word, like a cloudy red and then a bright red center dot, and the bright red center dot should be centered in your cloudy red dot, transparent kind of red dot. Okay, now you're gonna see here I got set up, and down below I put a metal plate on the floor because the laser, when it goes through your material that you're cutting, it actually will burn the floor. I'll put a piece of cardboard down there. We'll see if she lights on fire, but it will mark up your floor. So I put this piece of sheet steel below there just so it doesn't mark up my concrete. All right, I've got this piece of aluminum here. I just clamped this guide to it, and we're gonna cut. And this is kind of a little bit annoying that you gotta clamp this ground to this for cutting, but let's see how it goes. Okay, so there was a nice cut. We're running at, let me just check. Looks like we're running at about 52 PSI. And there's a decent cut, very little dross. Let's try turning up the air pressure a little bit more and see what happens. We'll go to 60. All right, this time, you see when I cut here, the red dot is on the cardboard. Let's try it. There you see how much laser power is going through, not so much when you're cutting, but when you start and when you finish. That is how powerful that laser is from a 3-foot distance. It's lighting this cardboard on fire. That's why I put this metal on the ground, so you're not scorching your concrete and maybe overheat the concrete or something and make it chip and pop and yeah, just wrecking your property. So you definitely want to be careful where you're pointing that laser. I mean, 3 feet away and it lights that cardboard up on fire, no problem. So like I said in the beginning of the video, I managed to burn through a leather welding glove and into the tip of my finger here, just a little bit, just the lightest little burn, but it was a buzzing sensation and I pulled my hand away right away. I knew what was going on, and it's just something to be aware with these laser welder cutters. They're fairly powerful, even 700 watts, and this is a relatively low powered laser. Could you imagine a 20,000 power one? That would have blew a hole through my finger, probably. Definitely something to be aware of. Okay, here we just have some mild steel. We never changed nothing in the settings or anything. We're just doing what the pre-settings for cutting. Let's see how it cuts. I think this is 16 gauge. Maybe 12 gauge. Wow. See how fast we can cut this thick of metal. Again, these are just coupons for welding later in the video here. That was moving pretty fast. That's pretty impressive. I'm gonna mic this just so you guys got a thickness. This is 100 thou, 106 thou, and you've seen the speed at which it cut. Pretty awesome. Imagine if you cut thinner stuff like 22 gauge or something like that for body work, it would be even faster. Let's cut some more. I don't know, man, that's impressive. It's relatively low powered and it cuts that 100 thou sheet metal super easy. We got lots of coupons now for weld testing. Got this chunk of stainless, and you can see I've been doing some bead testing before, just trying to figure this machine out. Like I said, they don't give you much instruction on how to set this machine up. So let's see how she cuts stainless. Yeah. This stainless is 110 thou, basically the same thickness as our mild steel. Okay, I'm going to give you a level view of this cutting through stainless. We can see how far the shower goes down, how much shower goes down. Well, it cuts the stainless. It cuts the stainless just as easy as it cut mild steel. It does have a funny dross, an interesting dross. I'm just going to cut it down into a shorter section for weld testing. That way we can weld these joints together. So far I'm right impressed. I mean, it cuts the stainless steel at basically the same speed as you're cutting mild steel. I'm not sure. I would have thought that there'd be a little bit of difference. Obviously you got to go slower with aluminum, quite a bit slower, but it was a little bit thicker material. Also, I think I have some little bit thicker stainless we can try and cut. This here's 100 thou. I'm going to cut a few more of these guys just for weld testing, and then I'll see if I can find a little bit thicker steel, maybe some thicker stainless, cut that up because we'll try and weld it. I've got this, I don't know, I think it would be super hard to cut through this quarter checker plate here, but I did do a weld on it, pretty cool, and I'm going to show you a setting that I found out that I haven't seen anywhere else. So I'm going to just keep cutting this up, and then I'll come back to the thicker stuff and show you guys. Okay, so that's, it can't do it. It's just impractical for you to try and hand cut this. I just can't move slow enough to cut through. It was cutting through, but not with any sort of consistency, and it's just way too slow. If you had a CNC, this unit set up on a CNC cutter, and you could move at a nice, consistent, super slow motion, you probably could cut this thickness of metal, but it would be really slow. But it would still do it with a fine kerf, apparently. I'm going to cut this in the plasma cutter. Just this strip here, cut it into a few pieces just for weld testing, see if we can weld 1/4 inch stainless steel. I kind of doubt it, but we'll find out. So let me cut this in the plasma cutter and we'll more than likely move on to welding. Okay, so here we have some mild steel 22 gauge sheet metal, bodywork type metal. Let's just see how it cuts. Boom! Yeah, man, you can zing along with that stuff. Wow. Let's cut another piece here. Impressive. It's so far from what I'm seeing is this thing would be awesome for sheet metal work and light stuff, probably up to 1/8 gauge or 1/8 inch, you know, 12 gauge, 11 gauge type stuff. So far, pretty cool. Let's give it. Wow. Wow, it cuts that 22 gauge like crazy fast. And like zero heat input. Didn't even change the temperature of the edge that I can see with my bare eye. That's pretty awesome. That could be awesome for cutting out sections of auto body panel, which we may find out this winter when I do some body work on the old square body Chevy that I got. We'll be more than likely we'll be trying this laser welder out on that. So you guys are going to want to stay tuned and to the channel. Make sure you subscribe and share and like these videos. Give me a thumbs up. And make sure you ring the bell if you want to see that video of me attempting body work with this thing. The bell will notify you when that video comes up. All right, we got ourselves a nice assortment of aluminum, stainless steel, and mild steel in different thicknesses, all cut up. Quite a few coupons to weld on, so let's set her up for welding and see how she does. All right, so it's fairly simple to go from the cutting tip to a welding tip. You can see I've used this one before. It's not shiny and copper like this one that I've just barely used. I've definitely done some testing. So you basically make sure your machine is off. Take the one tip out. Screw the other tip in. You want to make sure the little wire feed things, hopefully this shows up, these little wire feed notches are straight down on the bottom. And put the wire feed mechanism on. Tighten her up with the little tools that they supply, and we should be good to turn the machine on and feed some wire out. We're going to start with aluminum welding because that's what I've got on the spool right now, and this is 040 if I remember right. 4043 1.2 millimeter wire I have on here. So let's turn the machine on. All right, and it's just as simple as selecting welding, confirm, and there it's set up for just its generic setting, 5 millimeter. Maybe that's where I was at last time. But you go up in here and you select aluminum. What I'd like to see in their manual is an explanation of what all these abbreviations are, like SUS, stainless steel maybe, CS, carbon steel, but SECC, aluminum is probably AL, but UDT and OTS, no idea what those mean. It would be nice to have an explanation for that. And this over here is your millimeters of thickness of steel that, or metal that you're going to weld. So what we're going to do now is we're going to take the air supply off and run this hose over to our argon bottle and hook it into our argon regulator. Figure out what thickness of aluminum we're going to start welding with, set her up, and see how it goes just off its parameters. So it is fairly simple to swap over if you have these parts. Like I said earlier in the video, you need these little quick connects for this 6 millimeter hose, and it makes it pretty simple to switch from cutting to welding, you know, to cleaning. You need to always run some sort of gas while you're cleaning. You can't just run it without. The machine won't fire up for you if it doesn't see any sort of either air pressure or gas pressure. So I've been just using air for cleaning and cutting. I haven't used nitrogen for cutting or anything like that, but I do have a bottle of nitrogen here, which was not, people say it's cheap, but it's not really cheap. I had to get this regulator here, which cost me a couple $100 for the regulator. I had to get a bottle of nitrogen, which I didn't have. You can't buy the bottles here, you have to rent them. So now I got this big bottle of nitrogen, but hopefully this machine is going to work awesome and it won't be no big deal. I've also had to buy some stainless steel wire in a 10-pounder because that's one of the things that I wish they would have for their wire feed unit. I wish they would have a conversion for a small roll. I don't do a whole lot of stainless here, so I mean I could have made up a little spool holder and whatnot for a little 2-pound roll of stainless steel wire, but it was just easier for me to go buy a 10-pound roll of stainless and then I got it. So I mean that cost me $100. I've put a bunch of money into doing this video besides them giving this to me. So that being said, let's have at her. Okay, so this is the first aluminum that we're going to attempt to weld. Looks like it's 0.1, whoop, let's go to millimeters. It's 3 millimeter thick aluminum. So we're just going to select 3 millimeter. We're on the aluminum setting already. Hit the check mark. This is the power. setting, it's basically saying to use a 5mm swing width, looks like 100% power, 48 Hertz. All we have to do now is turn on our power, confirm, yes, turn on the wire feed, check our gas is flowing, all good. We should be good to try it out. I gotta say, it's kind of nice that they give you a gun holder like this. It's just handy, nice place. It's kind of an odd gun. I mean, you can lay it down like that, but it's nice that they give you this holder. Comes with the machine. Wow, that's a pretty nice looking weld. Yes, it's hot. Not bad. But it looks like you could just break it. Let's have a look at that. Oh, that's a lot nicer looking weld. That's pretty decent. Like hardly any cleaning of the weld or of the material. I mean, it does make welding aluminum pretty easy. Welding aluminum in general is really tricky. You got to usually clean it super nice, super clean with acetone and stuff. I would say that's a pretty good weld. And fast, like definitely way faster than welding with a TIG. I slowed the wire speed down. I kept it 100%. That was welding at 8mm a second, and I did a 3mm wide bead on that. Seemed to weld pretty nice. Not too bad. Had to get my angle figured. Almost full penetration on that. We'll let this cool and I'll show you a trick that I learned. Now, while I was playing with this welder, you have continuous and you have pulse here. That's cool, but in your wire feed, you have continuous and you have pulse also. So what I found is if you need to penetrate deeper, you can leave the laser itself on continuous. You can go into your wire feed, put it on pulse, crank up your wire feed to say 30mm a second, and then you change your pulse cycles. So you slow your pulse down. It feeds it fast, but it slows the pulse down. But your laser keeps on welding. So you can put more heat into the part and then stab a big wad of aluminum wire in there. And it moves you slower, a lot like TIG welding, but it puts more heat into it, more penetration in. All right, so let's see if we can reenact that. Notice how the laser isn't pulsing, it's just the wire. See that? And you're putting in a fair bit of heat and you're getting a real nice bead, a lot like a TIG welder. So if you put that onto an outside joint. Let's just set this up again. Notice how the laser is staying steady on. We're putting a lot more heat into this part. Got to excuse I was jumping around a little bit. I wasn't running the right angle. But now when you look at it, we've got a little more penetration here than we had on this weld here. Not much, but a little bit more. But we can slow that down even more and feed more wire into it. What we have here is some 1/4 inch checker plate. So let's set up this weld and see if we can make a nice wide strong weld on this. We can change this cycle. Let's see what will it allow us to do. 1,000? Nope, so we're only divisible by hundreds. So the slowest we can make this thing pulse would be probably 999. Confirm. Now that's going to be the slowest pulse we can do, and then however much wire we want to stuff into it, we'll go with 30 millimeters a second. We'll stay there. And we'll keep the swing width at 3 millimeters a second and see what that does, and then we'll change it to 5 millimeters. Well, unfortunately, my recording didn't go. So all I did is I just finished the weld. Same power, same speed, same pulse setting. It looks like it could have had a little more wire feed in it. And on the back side here, you can see that it didn't have any full penetration, but it's bit in there pretty good. Let's do another bead, 5 millimeter wide, should be able to go from corner to corner hopefully. And we'll inject a little more wire and we'll keep the pulse that slow. All right, so you can see we're 100% power, 48 hertz swing, 3 millimeter swing width. We want to go wider. So we'll take that all the way to 5. Then we'll go into the wire feed. We'll crank up this speed. We'll feed a little more wire into it. We'll go with 40, see what that does. We already have the pulse cycle at 99. That's as slow as we can go. Let's see what kind of a bead she lays down. Yeah, I'm not sure what happened there at the end, but it started laying down a pretty nice bead. Definitely got the machine hot. We're running her probably as hard as you can possibly run it. And we almost went from corner to corner. Looks like it could have used a little more filler material. We could turn that wire speed up And here's how it looked after I increased it to 50 millimeters, the wire feed. Pretty decent. I'm guessing that'll be a fairly strong weld. It's hard to get focused on this shiny material, but you get the idea. So it welds aluminum pretty decent. I mean, I'm not a pro at aluminum welding. I can TIG some aluminum. It's not great, but it's decent, it's workable, and I've done good enough welds to pressure test for fuel tanks and stuff on jet boats. So, I mean, I'm not the greatest welder, but I can weld not too bad. And this laser welder, I think, will speed up the building of these aluminum fuel tanks for jet boats. And it'll be, for me, it'll be a consistent, decent looking weld compared to my TIG ability, and it'll be a lot faster. And for some reason, you don't have to have it as clean as you do with a TIG. Like, I never really cleaned this stuff. I just quickly ran it on my belt sander that's ground steel and wood and you name it. It's not aluminum exclusive belt. So it's interesting to me that aluminum doesn't have to be, seem to have to be as super clean as you do with a TIG or even a MIG. A MIG will deal with a lot dirtier aluminum than TIG will, but this laser is actually pretty darn impressive how it welds aluminum. Okay, now that we've shown that, let's move on to stainless steel. All right, this is after I've recorded the video and everything. I went and I watched another couple videos, and I seen one online there where a guy was trying to weld the old pop cans together. And the problem I seen with him is he was trying to run it like a MIG welder or like a TIG, and that's not how these machines run. I've never welded a pop can together, so this is going to be a first. We're going to try and do it with this machine, how it's meant to be welded, and we're just going to see if we can do it. So let's fire this thing up, try and figure out what sort of settings we need, and let's see if we can weld the old pop can together. Everybody says that's a big test of your skill, you know, like with a TIG welder or something like that. We're going to try and do it with this laser. So let's see here. We're going to get her into the welding. Yes. We're going to hit aluminum. Better put my glasses on. We're going to go with 1 millimeter thickness, which is way thicker than pop can is. We're going to turn our argon on. We're also running 040 wire, 1.2 millimeter wire, which is, it's probably way too thick to weld a pop can with. What I'm going to do right off the get-go is it has a 2 millimeter swing width. We're going to stick with that, but we're going to drop the power way down. We're going to start down at 25% at first and see if it can start a weld or start a tack on here. If it can tack it, then we'll go from there and we'll see what she does. We'll turn the wire feed on. We'll purge some gas. That way we're good to go. All right, we should be good to try and see if we can do a tack weld on this. All right, so I just want to say I am not a professional welder. I do this as a hobby. I have worked in multiple welding shops. I can TIG weld, kind of. I do lots of MIG weld. But this is a first for laser. I'm sorry, I'm going to have to put my hand over top to try and hold this steady and see if I can get a tack. So we're basically not making contact. Let's put the clamp on the gun, that way we will have contact, and we'll see what we can do here. 25% is not enough. Let's go up to 35%. We're going to cut this wire off to give it a fair shake. Try again. Well, we got a light tack on it. I believe we need a little more juice yet. And I could feel it reflecting onto my glove a little bit. I think we need just a touch more juice here. My wire thickness, I think, is a bit too much. A little too much juice. It is welded together, but not great. I think what I need to do is put the swing width a little wider. Well, it's welded, but I mean it's welded strong. Pretty cool. All right, so I got thinking about it, and I think I was thinking about it wrong. I went with a wider bead width. I think we want to go narrower. That way it puts more heat into the wire, burns that 040 wire, and welds just the seam. So let's try, instead of 2 millimeter, we're going to go down with a 1 millimeter or 1.2 millimeter at the 45% power and see what happens. Look at that, hey? Look at that. I think I just successfully welded the pop can together. Right, well, it can be done. I watched a video where a pro couldn't figure it out, but not knocking him for his welding ability. I'm sure with his typical welding, he's a pro. But these laser welders are a different animal altogether, and you have to think about it differently. And it's possible to weld pop cans together and not blow through it. That's what I mean. This machine will do super thin material relatively easy. I did this on my second try, and I just had to think about it a little bit. After my first try, I got thinking about it, and my making the swing width wider was not the answer. It was to make it smaller swing width and get the power set right so it burns the wire at the same time while it's bonding with the parent metal. It is possible. Pretty awesome little machines. All right, so this stainless is, if you remember, 2.5 millimeter or 100 thou. So we're going to go to our metal. We're going to select this one because I'm hoping that's stainless, and you have either 2 or 3 millimeter. Let's go with 3. Call it good. Let's take any pulse off. Okay, and it's showing 5 millimeters a second to weld this thick of stainless steel. 100% power, 99% swing, and a 3 millimeter bead. Let's see what she does. These machine settings are going to change depending on the type of weld you do, but let's see what it does. Well, that was pretty fast. Let's see what it looks like. Pretty decent weld. It doesn't look like any sugaring. It looks like it hit it pretty hard. All right, let's just give it pulse. Will not change anything else. So the laser is pulsing. The wire feed is continuous. Let's see what that does. Grab another coupon. And I haven't seen anybody showing these types of tests. They're just plain old welding and saying, here you go, look at this thing, welds awesome. But let's play with this machine. Let's see what she can do. Here you can see the laser itself is pulsing, but the wire feed is steady. Very cool. Look at that. There we go. And that is just turning the pulse on. Here, let's see if we can get her to focus here. Here's your straight weld on the left. It's hard to get, it's pretty shiny. And there's your pulse on the right. Get her to focus, there you go. Pretty cool. That's just with the laser pulse. That's pretty interesting. It's neat how easy it makes stainless and aluminum welding. I mean, I don't do much stainless welding at all, and that is like the best stainless welding I've ever done. Makes you look like you're some sort of a pro. And from what I've seen on other people's videos, these welds are strong, like really strong. Like I'll be able to bend this right over 90 degrees and beyond and it won't break. We're going to weld half of this on the pulse setting and half of it on continuous. Pretty tiny little weld. More wire. Yeah, she's really smoking through. Let's feed more wire to it. We'll go with 350. Confirm. We'll crank the wire up to 40. Confirm. See what that does. Now we're getting somewhere. With that joint, it was a lot better. And we're still getting full penetration. Yeah. Try 500 on the pulse. And we'll leave that there, but we'll drop our power. Let's try 65%. 40 mil speed, 500 on the pulse. See how it does. Definitely much better on the corner weld. So as you can see, still full penetration. We just got to figure things out a little bit more. Let's drop the power some more and feed it a little more wire, and we'll widen the bead. Okay, feed it more wire. We'll hit it with 50 for kicks. Confirm. The pulse, we'll slow it down a little bit. Let's go 600. Confirm, which is going to put more heat into the part, right? So let's go back. We'll drop this to 50%. Confirm, and I want to swing this wider, which is probably still going to make it cooler. But I want to try and do a full bead. Ah, come on, across. Too much. Too much, too cold. Yeah, so we need more heat. The width of our bead is good. Not awesome. Our best setting was that one there. It's hitting with too much wire. So these are my settings and not the machine itself. I'm fiddling around with it, trying to see if I can get a weld that I want. I want the weld to go across from corner to corner, right across, and fill it properly. And you probably could do it with some messing around, but I'm starting to run out of material. But overall, this machine is pretty cool, and it will make the average welder look like a pretty decent welder. What you just have to understand is these settings. Some of them I don't understand. A lot of it relates to my lasers. Like I've got a fiber laser over there for engraving, laser engravers. And so it helps me figure this machine out. A lot of guys aren't going to have that knowledge, so it's going to take a little longer to figure out. If their manual would go into a little more depth on these settings and what they do and what you want to do and how to adjust it to get your specific output, that would be great. Their manual is very vague, and I would like to see it with way more information on how to set this up, how to weld properly and whatnot. Because if I was to just put the setting in there like you've seen it, the weld is real skimpy, and on an outside corner joint, it's not what I would like to see. Let's try a weld like this. That's a common weld that you would end up doing. Let's see how it does here. As you can see, it did a super nice bead, and the part is pretty hot for me to hang on to here without pliers. But a really nice bead, and sunk in probably fairly deep, but still a fairly narrow bead, and a lot of people would think that that's not a strong bead, but from watching multiple laser weld videos, that weld is going to be darn strong. There you can see 5mm wide bead. Having trouble focusing, it won't autofocus, so I'm just trying to manual focus it so you can have a look at this bead. Okay, let's change this to carbon steel and 1mm, because that's what 22 gauge is. Not quite a millimeter, and let's see what it can do with that. So I'm going to say your typical weld with 22 gauge body work type metal will be butt joint like this. Let's see what it does. And this is with adding metal to it. Right? We could try and autogenous weld this too to get an idea how well welding body metal would be. But here, let's go. Let's try this right now. Wow, look at that. Really low heat input, tiny little weld seam. And it's going to be up to you to stay on the actual seam for welding, because it does boogie along pretty good. But man, wouldn't that be something for body work? That's crazy good. All right, let's see how this does, see how I can do. This is also 035 wire. It might do better if it was 023. There, I fell off the weld seam, but still. Perfect. Low heat input, small little weld. And it's strong. That's not breaking. I mean, your body panel's not going to see that much abuse. It's breaking the parent metal and not the weld. Pretty awesome. All right, we got some thicker stuff. 16 gauge or something like that. See what it'll do with this type of a weld, and we'll wrap the video up. I'm going to weld some of this on a 2mm setting, and then I'm going to change to a 3mm setting, because this is actually 2.5 millimeters. So let's see what it does. See if I can stay on the seam. Yeah, it took me a little bit. Just to show you what we're doing here is we're going to select 3mm carbon steel. I'll leave just a little gap here so we can tell the difference between the two welds. More heat, for sure. Full penetration, no penetration. All right, so what you're looking at here is the 2mm setting and the 3mm setting. There's more wire on top here, or more bead on top here than there is there. But when you flip it over, you have no penetration there and you have full penetration there. So you don't have an option for 2.5mm to get in between, but you could change your wire feed, or you could pulse it, or whatever. Pretty impressive. So, final thoughts on this laser welder. I think it's pretty awesome. It's super tunable, super adjustable. All the parameters and stuff you can adjust on it makes you be able to weld super thin stuff to medium thickness stuff, or maybe not medium thickness, but up to 3/16. Really quite easy. I have nothing really bad to say about it. Everything looks like it's built quality. Everything works as it should. It pushes aluminum wire through the stinger without any trouble. I did have one bird nest when I was first testing, but I just might not have had it set up right. But yeah, it's a pretty good unit, I think. If you're looking for a welder to weld basically 1/8 inch to super thin stuff, I think the laser welding is an option. You should probably take a look at it. They are relatively expensive. I mean, for the home hobby shop sort of thing, you know, they're probably $6 grand or something like that, which is, it's getting you up into the big name MIG welder type stuff, Miller, you know, all the other big name guys. But I do want to say, laser welding is here. It's real, because the big guys like Miller and Everlast and them are making laser welders. You can go online and you can see it, and they're making them. So laser welding is a true process. It's been done for years and years and years in the commercial setting. So it's not some gimmick. Maybe some of the cheap ones are a little gimmicky. They're not running enough power and you just can't use them properly to weld with. But this thing is not a gimmick. It does weld, and it does what it claims to do. And if you run it how it's meant to run, don't try and weld it with it like a MIG welder or whatever. You run it how it's meant to run. The thing welds great, does what it's supposed to do, penetrates like it's supposed to do, and don't expect it to weld 1/4 inch or 1/2 inch or stuff. You're going to be disappointed. It doesn't have enough juice. You need a bigger, more higher wattage machine to do that. So I think it's a pretty good machine. And I think you guys should like and subscribe to my videos. Make sure you share them, give them a thumbs up, hit the bell to be notified, and we'll catch you guys on the next episode.